When the form is completed, you are now ready to start putting in the Visual Basic code. If you look at the 4 input cells, the first thing we need to do is open up the developer and the Visual Basic code, and this opens up a window that allows us to put in code. That's just something I had in there earlier. And when I click on this button here, the button is called Button Calculate, and it automatically comes up with a subroutine called Button Calculate, and it's linked to the event click. There are other events here as well, but the one we normally use is the click event. So you can see how when the user interacts with that button and clicks on it, the code within the subroutine is going to be executed. Now the first thing you need to do is decide what variable name you're going to give to each of the values that are going to be read in, and what type of information is going to be stored in each variable. Well, if we look at this, the width can be a real number. That means it can have a decimal part. The gate could be 2.5 meters wide, or the plate could be 2.5 meters wide. The height could be 3.5 or 3.25. So we need real numbers in here. Same with y bar, that's the distance in the surface down. You can have a decimal part, and the angle as well in degrees can have a decimal part. So every number we have, we can put it in as a single type. So what I do here is I dimension, use the dim keyword. And the first one I'm going to do is for the width I'm going to use b, because if you look at the formula, a is equal to b times d. So for the width, the logical term to use, the logical variable name is b. And I declare that to be single. So that's going to hold a real number with 7 significant figures. It's called single precision. Then the next one is the height, but because that's d in the formula here, I'll use d. Then the next one is y bar. So I'll use capital Y bar as single. And you can see as I start typing it, it comes up in the context menu. The last one here for the input is phi. So I call that phi as single. So there are variables for my input variables. What I'm actually going to call it is phi d degree as a single, because I'm reading those in degrees. Okay, so that's our first statement there, where we assign variables for each of the input values, and we define them all to be of single type. That means they're going to have a decimal part. What I'd advise you to do here is to pause the video for a minute, have a look here, and come up with variable names for these 4 output values. Now before you do that, what I would suggest is the sine function. If you look at the formula here, the sine function here uses radians, the degree in radians, but you've asked the user to put it in degrees. So I'm going to declare an intermediate variable. I'll do this bit here, dim phi rad, or radians, as a single also. So we'll use that variable to convert the angle in degrees to an angle in radians, because then we can feed that into the sine function here. So if you pause now, pause the video, and come up with 4 suitable names for these output, the area, the second moment of area, the resultant, and d, the centered pressure. Now you can't use the variable name d again because it's been used up here for this variable. Okay, so I'm going to start typing in some versions of it here. So dim a as single. I'll use the variable a for the area. ig as a single. I'll use that to store the value for the second moment of area, or as single for the resultant force, and d, and I'll just call it COP for center of pressure as a single, just to differentiate it from the other d up here. So I have all my variables declared. So the first thing I need to do is the input section. So if we come back here, what we need to do is when the user runs this program, the text boxes will appear, they'll put values in. What you need to do, the first thing you need to do is read the values that the user has put in here into the variables which are stored in the RAM or random access memory of the computer. So I'll use a comment here, so the quotation mark and input section. And I use assignment statements. So I say B is equal to text, and I call that width. If you remember the control out here, I called it text B, in fact, not text width. So if I come back here, it's text B. And I know if I've done it correctly, because when I hit a full stop, if that control exists out in the form, this context menu will come up. Whereas if I had said text width and a full stop, if nothing comes up, that means that I have not named the text box as text width, so I want to go back and check. But if I do text B, full stop, it comes up. Now the property that shows what's displayed within the text box is the text property. So you can see it comes up there, and I'll select that. So what this statement will do when it executes, it's whatever the user has put into that text box gets assigned into the variable B. Likewise, I'll do it for the next one. So if we go back here, this is text D, and we want to read the value there into the variable D. So text D, full stop, text. And that's that one. The next one is Y bar, and that's in text, Y bar, full stop. The context menu comes up, so I know it's correct. I start to type, and after pressing the T and D, you can see it comes up automatically. I can just press the tab button to finish it out. And the last one is phi degree is equal to text phi, full stop. It comes up, the context menu comes up, so I know I've done it correctly. And that is those 4 values there. So I can run this with the F8 button, and what the F8 button does, it goes through a step-by-step. So if I run it with the F8 button, it automatically puts the form up on the screen. So say I say that's 2, I'll give that a value of 3, I'll say it's 6 is the distance from the surface down to the center of gravity of the plate, and I'll say it's an angle of 45 degrees. Now I haven't done the calcs yet, all I've done is the input section, but with the F8 button, what I can then do is it'll skip all the dimension statements, and it comes down to the first assignment statement. And you can see here that if I come down here, I've executed that statement. So if I come down here and say print B, D, Y bar, and phi degree, you can see that the 2 read incorrectly. Remember, I put in 2 when I ran it for B, but this line hasn't executed yet, so D is still 0, Y bar is still 0, and phi degree is still 0. If I then come and execute this line, and then click into what's known as the immediate window down here, and I press enter again, it'll execute that command again. But now you see that B is 2, D is 3, so it's now read in the 3 from the text box. Y bar and phi degree are still 0 because we haven't executed these 2 lines yet. When I execute this line, you can now see that the Y bar value has been read in. And when I execute this line, you now see that the 45 degrees has also been read in. So by pressing the F8 button, I can check that the input section has worked before I come and do my calculations. So that's fine, and I just press that to stop it, the reset button up here. So if I then click back in, I'm ready to do the calculation stage. And the calculation is given here in the handout that you have, and I have it out here in the spreadsheet. The 4 equations are here. A is equal to BD. Now actually there's a bit of an error there. That should be IG is BD cubed over 12, not BD squared. So I'll get that right when I'm doing it here. So the first one we want is A. So the area, the variable A will hold the area. So say A is equal to B multiplied by D, like so. Then I say IG is equal to, and you need brackets around here, multiplied by D to the power n. You need a space after that. This symbol, it's above the 6, is called the caret or caret. That is the power symbol. I close that bracket, so everything in the numerator, which is the BD cubed, now I know I have a BD squared here, it should be BD cubed, is in the bracket. and then we divide the result of that calculation by 12. Then the next calculation is OR is equal to rho G AY bar. Now I need to come up here, I forgot to do this. I need to define rho, or HO, as a single, and G as a single. I can define it as a constant, I'll just leave it like that for the moment. And here what I'll do is have a section to set constants. Set constant values, I'll put it up here and I'll say rho is equal to 1000, which it is for water, and G is equal to 9.81 meters squared per second. So I just pull this up a little bit. There are all our symbols. You can see I have a section here at the start to set the constant values. Then I read in BD, Y bar and phi degree from the text boxes. Then I have the first two calculations done. And then if I come here, I have this one, which is the resultant force due to all that water pressing down on the plate, is equal to rho G. So it's density of water times gravity times the area of the plate multiplied by Y bar. So you can see we have all those values. So we say OR, that's the variable that we're using up here. So OR is equal to, for the resultant, is equal to rho multiplied by G, multiplied by A, which we worked out, multiplied by Y bar. And then the last formula is tricky enough. It's D is equal to Y times AG over AY bar times sine squared phi. Now, as I said already, this sine function takes the degree in radians, so I have to convert it. So what it is phi in radians. Remember, I set up this variable up here to store it, is equal to phi degree. What is it? Divided by 180. Because if you remember, 1 pi radian is equivalent to 180 degrees. Multiply by, and if you want to use a function that's out in Excel, you can use the worksheet function command. So you can actually use existing worksheet functions that you know that you've used before in Excel. You can use them in the VB. And the one we're looking for here is the pi value. Okay, so now we're ready to say D, and the variable name I use is center pressure, so COP, D COP is equal to Y bar plus, and if you look at the formula out here, I'm going to do IG multiplied by sine phi squared divided by A divided by Y. So I'm going to say that IG times the sine squared phi is the numerator on top. So I have a bracket for that, and look at it again. Yeah, IG multiplied by sine, and it's phi in radians. I just say that is to be squared, to space it out and close the bracket. So that's numerator done. And on the denominator we have A multiplied by Y bar. So I have A multiplied by Y bar. Okay, so we have everything worked out. But you have to remember they're all worked out in the memory of the computer. So what we need to do is output them. Do for output, we're going to use text boxes for output, is, if you remember, I've named these text boxes: text area, text IG, text OR, text DCOP. So if you look at this one in your assignment statement, when you're doing input, on the right hand side you have the control, on the left hand side you have the variable. When you're going the other way, it's text area dot text is equal to A. So it's the other way around. On the output section, the controls are on the left hand side of the assignment statement and the variables are on the right hand side. Then we have here text IG, text that is equal to IG. So remember, these values here are stored in the memory of the computer. It's only when you actually put them back out onto text boxes that the user can see them. Text_text, remember the text is the property. It determines what's displayed within that text box, and that is equal to big O, and text DCOP.text is equal to DCOP. So that's it, completed. So what I'll do is use the F8 button to go through it line by line again. So if I do it here, F8, I'll do 2 here, 3 meters, 6 meters from the surface, and we'll do the 45 degrees. And I say calculate R and D. I come down here, skips to dimension statements. We set rho is 1000, G is 9.8, and I read in B. What I'll do is I'll clear down here, and I'll do the input again. So B is equal to text B. So I'll get rid of this one. And I'll execute this statement. Sorry, I'll do all 4 of them. I'll execute it down here, and you can see that B is 2, D is 3, Y bar is 6, and phi degree is 45. So all 4 are being read incorrectly. So I'm going to delete this now, and I'm going to print out print A, the output values, IG, or phi radians, and DCOP. So at the moment they all contain 0, but if I come back up to the program, press F8 to execute this line, and I print them out, you can now see that the area is 6, and if you remember, it's 2 times 3, so it's correct. IG, if I work it out, is 4.5. So if you work that out, you would get 4.5, or is equal to rho times G times A times Y bar. So I execute that, and I print it out. And you can see you have a very big value here, so it might actually make more sense. It's 350,000, 160 and 160 newtons. Might make more sense to convert it to kilonewtons. So we'll do that in a second. Then the next statement here is converting the phi in degrees to phi in radians. So if I execute that statement, you can see we get 0.785. Now if you multiply 0.785 by 4, you'll get something close to 3.14, and that's pi. So if you remember, 45 degrees is pi over 4, so that's correct. And the last one here is DCOP. So if I multiply that, you can see it's worked out as 6.0625. So if Y bar is 6, you can see that the center pressure is always going to be below the centroid. And that makes sense when you look at the equation, because the equation says D is equal to the centroid plus this other term here, which is a finite term. So D to the center pressure is always going to be below the centroid. Now you can see here in the form, we've calculated these values. They're in the memory of the computer, but they're not displaying in our output text boxes yet. So if I come here, I can start outputting them out. So I'll execute this statement, come out and have a look, and you can see that's now populated that text box there. Execute the next statement. You can see the IG is now populated. Execute the next statement. You can see it's taken the value of 4 from the memory and put it out here. And execute the last statement, F8. And you can see it's given us the value of D. So what we kind of learned from this problem here is that these would be reasonable values for plates and sluice gates and so on, or fluids. So it might make sense to put this to kilonewtons. So if we do that, what we have to do is come here to or, put all of it in brackets. So if I want to convert from newtons to kilonewtons, I divide all of it by 1000. But to make that change here, if you remember here we have our label. So I'll just put a small k in front of newtons. So it's corrected and it's shown up as kilonewtons. Now if you're running and debugging a program, trying to get it right, it's always a good idea to put the values in text in here. So if I put in 2, preset the value 2 here, preset the value 3 here, put a value of 6 in here, put a value of 45 in there, And the advantage of this is that when you're debugging the program and getting it to work, you don't continually have to keep putting the values in. You can just set them at the start. When you know the program is working correctly, you can get rid of them afterwards. So you can see that now it's actually working. If I was going to go through it line by line with the F8 button, you can see they're already in there and you're not having to put them in again. So now I can come through here, F8, and you can see as I run through there, if I execute this statement, you can see it's calculated out all the results again. And then if I come to here, kind of repeating what I did before, but you can see it's transferring the values out like so. F8, 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 and finish it off. So you can see it's finished here with the results there. Okay, that's everything. Thank you very much for listening.